Mdadm is a Linux utility used to manage and monitor software RAID devices. The name is derived from the MD device nodes it administers or manages, and it replaced a previous utility mdctl. The original name was Mirrordisk, but was changed as the functionality increased. Mdadm is free software licensed under version 2 or later of the GNU General Public License, maintained and copyrighted to Neil Brown of SUSE. Overview: Linux software RAID configurations can include anything presented to the Linux kernel as a block device. This includes whole hard drives, and their partitions. RAID configurations RAID 0 a Euro block level striping. MD can handle devices of different lengths, the extra space on the larger device is then not striped. RAID 1 a Euro mirror. RAID 4 a Euro like RAID 0, but with an extra device for the parity. RAID 5 a Euro like RAID 4, but with the parity distributed across all devices. RAID 6 a Euro like RAID 5, but with 2 parity segments per stripe. RAID 10 a Euro take a number of RAID 1 mirror sets and stripe across them RAID 0 style. Note that RAID 10 is distinct from RAID 0+1, which consists of a top-level RAID 1 mirror composed of high-performance RAID 0 stripes directly across the physical hard disks. A single drive failure in a RAID 10 configuration results in one of the lower-level mirrors entering degraded mode, but the top-level stripe performing normally. A single drive failure in a RAID 0+1 configuration results in one of the lower-level stripes completely failing, and the top-level mirror entering degraded mode. Which of the two setups is preferable depends on the details of the application in question, such as whether or not spare disks are available, and how they should be spun up. Non-RAID configurations linear Euro concatenates a number of devices into a single large MD device. Multipath Euro provides multiple paths with failover to a single device. Faulty Euro a single device which emulates a number of disk fault scenarios for testing and development. Container Euro a group of devices managed as a single device, in which one can build RAID systems. Features: the original form of names for MD devices is MD, where is a number between 0 and 99. More recent kernels have support for names such as MD Home. Under 2.4x kernels and earlier these two were the only options. Both of them are non-partitionable. Since 2.6x kernels, a new type of MD device was introduced, a partitionable array. The device names were modified by changing MD to MDD. The partitions were identified by adding P. Thus MD-MDD to P3 for example. Since version 2.6.28 of the Linux kernel mainline, non-partitionable arrays can be partitioned, the partitions being referred to in the same way as for partitionable arrays Euro for example, MD-MD1P2. Since version 3.7 of the Linux kernel mainline, MD supports trim operations for the underlying solid-state drives, for linear, RAID 0, RAID 1, RAID 5 and RAID 10 layouts. Booting since support for MD is found in the kernel, there is an issue with using it before the kernel is running. Specifically, it will not be present if the bootloader is either Lilo or Grub Legacy. It may not be present for Grub 2. In order to circumvent this problem, a /boot file system must be used either without MD support, or else with RAID1. In the latter case, the system will boot by treating the RAID1 device as a normal file system, and once the system is running it can be remounted as MD and the second disk added to it. This will result in a catch-up, but /boot file systems are usually small. With more recent bootloaders it is possible to load the MD support as a kernel module through the init-ramps mechanism. This approach allows you to let the /boot file system be inside any RAID system without the need of a complex manual configuration. External metadata besides its own formats for RAID volumes metadata, Linux software RAID also supports external metadata formats, since version 2.6.27 of the Linux kernel and version 3.0 of the Mdadm user space utility. This allows Linux to use various firmware or driver-based RAID volumes, also known as fake RAID. As of October 2013, There are two supported formats of the external metadata, DDF, an industry standard defined by the Storage Networking Industry Association for increased interoperability. Volume metadata format used by the Intel Matrix RAID, implemented on many consumer-level motherboards. MDMPD MDMPD is a daemon used for monitoring MD multipath devices, developed by Red Hat as part of the Mdadm package. The program is used to monitor multipath devices, and is usually started at boot time as a service, and afterwards running as a daemon. Enterprise storage requirements often include the desire to have more than one way to talk to a single disk drive so that in the event of some failure to talk to a disk drive via one controller, the system can automatically switch to another controller and keep going. This is called multipath disk access. The Linux kernel implements multipath disk access via the software RAID stack known as the MD driver. The kernel portion of the MD multipath driver only handles routing I/O requests to the proper device and handling failures on the active path. It does not try to find out if a path that has previously failed might be working again. That's what this daemon does. Upon startup, the daemon will fork and place itself in the background. Then it reads the current state of the MD RAID arrays, saves that state, and then waits for the kernel to tell it something interesting has happened. It then wakes up, checks to see if any paths on a multipath device have failed, and if they have then it starts to poll the failed path once every 15 seconds until it starts working again. Once it starts working again, the daemon will then add the path back into the multipath MD device it was originally part of as a new spare path. If one is using the /proc file system, mdctl lists all active MD devices with information about them. MDMPD requires this to find arrays to monitor paths on and to get notification of interesting events. See also: Software RAID. References. External links, official website, Linux RAID Wiki, Kraft, Martin F. Mdadm recipes. Debian. Quick HOWTO, CH26, Linux software RAID linuximnetworking.com. Installation software RAID. Ubuntu Community Documentation March 1, 2012. Lonisa. Setting up a RAID volume in Linux with greater than 2 TB disks.